In this video, we're going to look at the naming of oxyacids. So an oxyacid always contains three elements. The first element is always hydrogen, very similar to our binary acids. Where it differs is that our last element is always oxygen. And what these are they are based on the oxyanions that we did in the previous video when they are combined with hydrogen. Important to keep in mind they're always in the aqueous state, so we always need to put AQ after our formulas to indicate it is an acid. Now let's just take a look at one of our oxyanions, which, if we're looking at the main one, would be our bromate ion. So in order to name the oxyacid, what you need to recognize is that it's combined with hydrogen. So anytime you see hydrogen first, it's indicating that it's the acid. It should also have an AQ written after it. I apologize, I didn't put that in here. So let's put that in now. Okay, so instead of calling this hydrogen bromate, because it's an acid, it is going to just become bromic acid. Okay, so the ic acid part is replacing the ate part of the name. If we have one extra oxygen, remember in terms of its oxyanion, this would be a perbromate. So in order to name the acid, it wouldn't be hydrogen perbromate, it would be perbromic acid. So we're using the per in front of the name, and we're using the ic acid for the ending. If we have one less oxygen, this is our bromite ion. And so instead of calling this hydrogen bromite, because it's an acid, we're going to call it bromous acid. So we're taking off the ite and we're adding OS acid to the end. And finally, the last one, hypo bromide. Okay, again, because it's an acid, we wouldn't call it hydrogen hypobromite. We would call it hypobromous acid. Okay, so for the acid, we're adding the hypo in front of the name, and we're using the OS acid ending. So any of the polyatomic ions that we've done have corresponding oxyacids, and it would be a really good idea if you went through each of those polyatomic ions that we did in the previous video and write out the names of their corresponding oxyacids.